Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions.
This particular paper is OCR November 2022, paper 6, higher tier.
Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it.
Question 1. Shape A and shape B are drawn on the coordinate grid. Yes, they are. Part A says, describe fully the single transformation that maps shape A onto shape B. Now, to me, this looks like it's just been picked up and moved, and we call that a type of transformation a translation. So for the first mark, you just need to write down the right word, which is translation. Now the second thing we need to do is write down the column vector, which describes how it's been translated, how it's been moved. Now to do that, we just need to pick a matching point on object and image. I'm going to pick this top right corner of shape A and the matching one on B, which is down here, and then I'm going to work out how far to the right and how far up it is from one point to the other. Okay, so if I want to go to A, the point on A to its matching point on B, I'm going to go 1, 2, 3, 4, 5 units to the right, and I'm going to go -1, -2, -3, -4, -5, -6 units up. So that was 5 along and -6 up. So to write that as a column vector then, which has to be in the form x, y, like that, with the number of units in the direction of x on the top and the number of units in the direction of y underneath, I'm going to write that down then as 5 minus 6. Okay, it's not a fraction, doesn't have a line in between, just one number sits on top of the other like that. Okay, right, let's just get rid of my counting. I'm sure you can count without drawing. Now the other one says reflect shape A in the line x equals -1. So we need to draw on the mirror line first, don't we? So x equals -1 is our mirror line. So drawing on our mirror line, there, look. What I'm going to do is I'm going to take every corner of my shape and then count how far it is to the mirror line and then do its mirror image on the opposite side. So that first point we marked earlier, you can see that's 1, 2 units away from the mirror line. So going 1, 2 units away from the mirror line, its image is going to be here. I can do that with every single point, just going around my shape, counting how far each point is from the mirror line and reflecting it like that. And then once we've got all the shapes, then we can join them up then afterwards. Boom, 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 boom. Okay, so there's my image of A reflected in the line x equals -1. Good job. Let's move on. Question 2. A recipe for a batch of jam needs 3 oranges, 5 lemons and 1.5 kilograms of sugar. A cook uses the recipe to make lots of batches of jam. They use 16 more lemons than oranges in total. Find how much sugar the cook should use. Okay, so we've got this ratio of oranges to lemons to sugar in the ratio of 3 to 5 to 1.5 then, don't we? Okay, and we're told that the difference between these two here is 16. There should be 16 more lemons and oranges. But if you have a look at the difference between the numbers, we've got 3 shares and 5 shares. So the difference between them is 2 shares. So if 2 shares is worth 16, then 1 share is going to be worth 8 then, isn't it? So that means if I then multiply that up by a factor of 8, then that should tell me actually how many of these things I have. So 3 times 8, that's going to be 8, 16, 24. 5 8s are 40. And 8 times 1.5, well, that's 12, isn't it? Okay, so just double checking that there is a gap of 16 between these two, isn't there? 24 plus 16 is 40, so that worked. So then this number on the end here has got to be our answer that we're looking for. How much sugar does the cook use? The cook uses 12 kilograms. Question 3. In 1980, Ling's flat was worth £23,000. Today's Ling's flat is worth 1,200% of its value in 1980, which is pretty much why all you guys are going to be living in a shed for your life or paying masses of rent. Anyway, but calculate the value of Ling's flat today. Well, let's think this through. I'm gonna use my little triangle final original multiplier to work out what's going on here. Now the final is the price after the percentage change. That is what we are looking for, isn't it? We're looking for the value of the flat today. What's the original value of the flat? Well, the original value is what it was worth in 1980. That's 23,000. So the original amount is 23,000. What is the multiplier? The multiplier is the percentage increase written as a decimal. Okay, so we're told it's worth 1,200% of its original value. Okay, so I think all we need to do is turn that into a decimal by dividing it by 100 then, isn't it? So what's 1,200% as a decimal? That's going to be 12 then, isn't it? 1,200 divided by 100 is 12. So the value of the house is worth 12 much what it was before. So 12 times as much as what it was before. So the final is equal to the original times the multiplier, which is 23,000 times 12. What's that then? 23,000 times 12, that comes to £276,000. Okay. There we go. Outrageous amount of money. Question 4. Sam and Taylor are playing a game against a computer. They can win, draw, or lose the game. Sam says, I think the probability of us winning the game is 0.3. Taylor says, I think the probability of us losing the game is 0.75. Explain why Sam and Taylor cannot be correct. Well, because there are 3 options, win, lose, and draw, and together those 3 options should add up to 1. But as it is, 0.3 plus 0.75, that comes to 1.05, which is too much, isn't it? Because 1 is certainty in probability, so you can't never have a probability over 1. So I'm just going to write down sum of probabilities should equal 1. Okay, I think I might add the word impossible in there because it's impossible to have a probability over 1. Part B says Sam is correct, the probability of them winning the game is 0.3. Taylor is not correct, the probability of them losing the game is actually 0.55. Complete this partially drawn tree diagram to show all the possible outcomes of playing the game twice. Okay, so we've got the first game. We've got 0.3 for winning and a 0.55 for losing. But what's the probability for drawing? Probability for a draw is going to be 1 minus the probability of win plus the probability of lose, isn't it? Okay, so that's going to be 1 minus, we've got 0.3 and 0.55. Well, 0.3 and 0.55 adds up to 0.85. You take that away from 1, it's going to leave me with a probability of 0.15. So that's going to be my probability for draw. So on this arm here, it's going to be 0.15, isn't it? Okay. Now, presumably, the outcomes are independent, and one game outcome does not affect the other. Otherwise, this would not be the case. But I'm going to have 0.15 in the middle there as well. But it's only partly drawn. I need to have 3 more branches here, don't I? So I need a win, draw, and lose branch here too. Win, draw, lose. And I need a win, draw, lose branch here down as well. Win, draw, lose. And because each outcome is independent of each other, all the probabilities are the same on each branch. Okay, because the first outcome is not affecting the seconds, presumably. Okay, so there we go. That's the complete diagram like that. Part C says, find the probability that they win the first game and lose the second game. Well, that would be this route then, wouldn't it? Win and then loss. So looking at the values along that path, I got 0.3 and I've got 0.55 along those 2 branches. So then the probability of winning the first game, losing the second game, is just going to be 0.3 multiplied by 0.55. 0.3 times 0.55, that comes to be 0.165. Okay? Question 5. In space, distances can be measured in astronomical units. In this question, use the conversion 1 astronomical unit equals 1.5 times 10 to the 8 kilometers. So it's pretty big. On a particular day, the distance from Earth to Neptune is 29.09 astronomical units. Calculate the distance from Earth to Neptune in kilometers on that day. Give your answer in standard form. Okay. So we've got 29.09 astronomical units, and basically we need just to convert them into kilometers using 1 astronomical unit equals 1.5 times 10 to the 8 kilometers. So we just really need to multiply them together, don't we? So the distance then is going to be the 29.09 astronomical units times the 1.5 times 10 to the 8 conversion factor then, isn't it? Now what I'm going to do is I'm just going to multiply these the mantissa part of my number with the number of astronomical units first, and then I think I'm going to try and then convert that back into standard form. I think that would be easier to do because I think my calculator will explode if I try and type that big number into it. So let's just do 29.09 times 1.5 to start with. That's given me 43.635. 43.635, and that's still going to be times 10 to the 8, isn't it? Okay. Now this number is not quite in standard form because the numbery part at the beginning needs to be a number between 1 and 10. But if I take another 10 out of it, divide it by 10, 4.3635, and then add that 10 into the exponent part, I'll get 4.365 times 10 to the 9. And that's going to be my answer. 4.3635 times 10 to the power of 9. Part B, on a particular day, the distance from Earth to Mars is, how many zeros is that? 78,340,000 kilometers. Calculate the distance from Earth to Mars in astronomical units on that day. Okay, so we'll go back the other way this time. We're starting in kilometers and we want to convert into astronomical units. So last time we had to multiply, didn't we? So I think this time we're going to have to end up dividing. So I'm going to have 78,340,000 divided by 1.5 times 10 to the 8. I'm just going to use the calculator function to do that. So 78340,000 divided by, then I'm going to put in 1.5, press the exponent key, and then put in the power of 8 and see what that comes out of that then. I make that 0.52, and change. I'm going to just write it down to two different figures, I think. So that's 3. Let's go 3. So 0.522 astronomical units. Okay, so that's what my answer is, 0.522. Question 6. The scatter diagram shows the number of visitors to a children's playground and the maximum temperature on 15 Saturdays in summer. We've got a lovely scatter graph here, and then part A says, describe the type of correlation shown in the scatter diagram. Okay, well I hope you can see that most of the points lie in this kind of upwardly moving line under the ruler here. Now I've got one weird point that doesn't, but all the rest kind of in quite a narrow band going up the page like that. So from left to right, they're sloping upwards, so we call this positive correlation. Positive correlation. One Saturday was a hot but stormy day. Circle the most likely point on the scatter diagram for this Saturday. So yeah, if it was stormy, not many people are going to come along, are they? So it's hot but stormy, rainy. I'm guessing it's you. You're the outlier, aren't you? You're the weird one. I think it's going to be that one there. Okay. Explain why you chose this point. Well, I chose it because it was hot, but the number of visitors was low. It was warm weather, but number of visitors was low. It's an outlier. Outlier. Okay. Use a line of best fit to predict the number of visitors on a Saturday that has a maximum temperature of 21 degrees. Okay, so let's put the line of best fit in first. You can see it was roughly going up in a band like that, so I'm going to put my line of best fit kind of in the middle of that. Try and get the same number of points on either side of the line, kind of following the general trend up there. Look, I think that's looking good. I'm going to go something like that, I think. Now it doesn't have to be exactly the same as mine when you're drawing yours. Okay, just kind of there or thereabouts. It's not an exact science. Yeah, so I've done mine like that. Now, use your line of best fit to predict the number of visitors on a Saturday that has a maximum temperature of 21 degrees. So let's look up at 21 degrees then. So I've got like 10 little squares between 20 and 25. So 2 squares is going to be 1 unit. So 2 little squares above 20 is going to be 21. So I'm going to read up to my line of best fit from there. Okay, when I hit the curve, I'm going to change direction and I'm going to read across. And then hopefully that will tell me the number of visitors. Okay. So that is pointing to there. Now again, if I have a look at the number of divisions between here and here, there are 10 divisions, but it's spanning 20 units this time. So each division is going to be worth 2. I make that 1, 2, 3 little squares above 60, which is 66 then, isn't it? So I'm going to estimate 66. Now if you draw your line of best fit slightly differently to mine, you're going to get a slightly different answer. It's very possible. I'm looking at mine and thinking, well, perhaps I did it slightly higher at the upper end. But anyway, you know, you do get some variation. Just the examiner will mark your work against your line. So whatever your line is, that's the right answer for your answer. Okay. Question 7. A child has 4 identical wooden cubes of side length 6. They arrange the cubes in a 2 by 2 by 1 arrangement to form a cuboid. Show that the surface area of a cuboid is 576 square centimeters. Okay. Now let's just consider the area of one face to start with. What's the area of one face of a cube here? This is going to be area of 6 times 6, then, isn't it? Because it's a square. So each face has an area of 36 centimeters squared. So really we just need to work out the number of faces showing on our arrangement and then multiply it through by 36 then, don't we? Okay, so how many do we have? Well, on the top of this we've got 4. So we've got 4 on the top. We're going to have matching 4 on the bottom as well, aren't we? And then we've got 2 on the side, 2 on the front, 2 on the side, and 2 on the back. So we've got 2, 2, 2, and 2 then, haven't we? So all together we've got 4, 8, 10, 12, 14, 16 faces. So number of faces is going to be 4 plus 4 plus 2 plus 2 plus 2 plus 2, which comes to 16 faces. So then the total surface area then is going to be those 16 faces multiplied by the 36 area of each face. 16 times 36, I'm guessing it's 576. Yes, it is. So that is 576 centimeters squared as required. Now part B says the child rearranges the cubes in a 4 by 1 by 1 arrangement to form a different cuboid. Calculate the percentage increase in surface area of this cuboid compared to the 2 by 2 by 1 one. Okay, so how many faces does this one have? Number of faces of this. Well, I've got 4 along the top, 4 along the front, 4 along the bottom, 4 along the back, haven't I? So I've got 4 lots of 4 faces, plus I've got that one there and that one there then at the other side. So I've got 2 plus 2 faces at the ends. So what's that? 18. That's 18 faces. Now the last one had 16 faces. Now I could use like the area of the surface area. I could just use the number of faces because I'm just looking at a percentage increase, aren't I? So it's increased from 16 to 18 faces, and I want to know what the percentage increase is. So final, original, multiplier. So the final is 18 faces. The original was 16 faces. Like I say, you can work out the surface areas and use those as well, but it's just a little bit more work. And then multiplier is that's the thing I want to find then, isn't it? I want to work out how it's changed. So covering up the thing I want to find, multiplier, that is final divided by original. So multiplier equals final over original, which is 18 over 16. What's that then? 18 divided by 16, that comes out to be 1.125. Now remember that's a decimal, and as a percentage that would be 112.5%. So as a percentage increase, that's going to be an increase of, well remember you start with 100%, so if we started with 100 and now I've got 112.5, it's increased by 12.5%, so that is a 12.5% increase. Question 8. Triangles ABC and DEF are mathematically similar. Angles ABC equals angle DEF. Calculate the perimeter of triangle ABC. Okay, so what's going with what then? And we're told that angle ABC goes with angle DEF. So ABC is that one, DEF is that one there. They're the matching angles. Okay, so presumably the side opposite match the side opposite. So those two go together on this similar triangle. What about this one here? Does the 15 go with the 7 or does it go with the blank one? Now it seems to me that so the ABC is mathematically similar to DEF. So ABC goes first. So AB should match with DE. So AB, the first 2 letters of here are going to have to match with the first 2 letters of here, then DE. So it goes that way around, okay? So yeah, and then so this one must go with this one here, okay? So the 25 goes with the 10, the 15 goes with the blankety blank one, and the blankety blank one goes with the 7, okay? So now we've got one pair that match up. The 25 goes with the 10, so we can work out the scale factor from one to the other. And then we want to work out ABC, so we want to find the missing one on AB. So let's do the scale factor going this way. So 10 to 25, that's a scale factor of 2.5, isn't it? Because 10 times 2.5 is 25. 25 divided by 10 is 2.5. Okay, so that's a scale factor. So then that's going to be true of any side matching from one similar shape to the other. So if I take that 7 and I go over to over here, that is also going to be multiplied by 2.5 then, isn't it? So this one up here is going to be 7 times 2.5. What's that? That's 2 7s are 14 and half a 7 is 3.5. So that's 17.5. Okay, so that one's going to have to be 17.5. So then the perimeter of triangle ABC is going to be the 25 plus the 15 plus the 17.5 then, isn't it? Okay, what does that come to? 25 and 15 is 40. 57.5 seems reasonable to me. 57.5. Okay. Question 9. Given that 2 to the power k raised to the power 6 times 8 is equal to 2 to the power 45, find the value of k. Okay. I think the easiest way to do that is to make sure everything on both sides has the same base of 2, and then we can just simply compare the indices and equate them. Okay, so let's take what's on the left-hand side to start with. The left-hand side is equal to 2 to the power of k raised to the power of 6 times 8. Okay, well, 2 to the power k raised to the power 6, that's an index of an index, and what we do there is we multiply those two together, don't we? So that's going to give me 2 to the power of 6k. Okay, now 8 is 2 cubed, isn't it? So I can rewrite that as 2 cubed, and then 2 to the power 6k times 2 cubed. I've got two numbers with the same baselet, so I can just go ahead and add the indices together. That is going to be equal to 2 to the power of 6k plus 3. Okay, so we know the left hand side is equal to 2 to the power of 6k plus 3, and we know that that is equal to the right hand side, which is 2 to the power of 45. Okay, so again, look, we've got 2 on both sides, 2 and 2, and then so we can compare the indices. Then we can say, well, that bit there must be equal to that bit there. So equating indices, I know that 6k plus 3 is equal to 45. So now I've just got a simple linear equation in k that I can go on to solve then, can't I? So subtracting 3 from both sides, that's going to cancel. That's going to leave me with 6k is equal to 42. And then dividing both sides by 6, that will cancel, leaving me with k. 42 divided by 6, that's 7, isn't it? So k must be equal to 7. Question 10. The highest common factor, HCF, of two numbers is 14. The lowest common multiple, LCM, of the same two numbers is 210. The two numbers are not 14 and 210. Find your two numbers. Okay. Well, if I did prime factor decomposition on 14, you can just type it into your calculator. 14 equals, and then on the new calculator you just press the format key and then write it as a product of its primes. So 14 is equal to 2 times 7. If you do the same thing with 210, so 210 equals, and then writing that as a product of its primes. On the old button it's the fact key, isn't it, on the old calculator, but on this one you press format and then choose that option. That's 2 times 3 times 5 times 7. Now if I was to draw this as a Venn diagram, then the prime factors that appear in the HCF lie in the middle, 2 and 7. And then the prime factors that are in the LCM that are not in the middle, so we've already picked out 2 and 7, 2 and 7. Now the other two must be in one of the other outside circles. So this is our first number is made up of these, and this is our second number is made up of these. So either the 3 and the 5 are both in here, or you have one in each. You have the 3 in there and the 5 in there. If I put the 3 and 5 in the other one, it would just be the same two numbers reversed, wouldn't it? So either it's going to be like that, or it's going to be the 2 and the 7 and the 3 and the 5 in like that. Okay, so the first situation would make A 2 times 3 times 7, which is 6 sevens, that's equal to 42, and B would be 2 times 7 times 5, that would equal to 70, so that would be those pairs of numbers. In the other scenario, B would be equal to 14, and A would be equal to 2 times 7 times 3 times 5, which is 210. Okay, now we're told specifically that the two numbers are not 14 and 210, so that scenario is not what's happening. So it's going to have to be the other one then, that A is 42, or the first number is 42, and the next number is 70. Question 11, factorise fully 30x squared plus 2x minus 4. Okay, so it's going to hopefully go into at least a couple of brackets, but to make things simpler, I noticed that everything is even here. So just to make the numbers smaller and therefore the number of possible factors smaller, I'm going to factorise out 2 first out of everything. So that's going to give me 2 lots of 15x squared plus x minus 2. Okay? Okay, that makes it a little bit more simple. Now let's have a look at the coefficient of x squared, 15. Now the factor pairs of 15 are going to be 1 and 15 and 3 and 5. Okay? And the other factor pairs that we're interested in is minus 2, or 2. Factor pairs of 2 is very simple, it's just 1 and 2. Okay, so that makes things pretty easy for our numbery part, but we've got 2 possibilities for our x part here. So either this factorizes into 15x plus or minus something, x plus or minus something, or it factorizes into 3x and 5x. It's going to be one of those pairs. Okay, now the numbers have to be 1 and 2, and we're aiming for 1 in the middle. So either we put like 1 here, 2 here, or the other way around. That's going to be not going to work, is it? Because 15 times 2 is 30 already, and then that's going to give me 29. So that isn't going to work. It's not there. Trying the other way around. The 2 and the 1, again, not going to get close to 1 in that case. So it's definitely not 15 and 1. Let's try 3 and 5x then. So if I put the 2 here and the 1 here, it's not going to work, is it? Because that's going to give me 10x minus 3, which is 7x in the middle. That's not going to work. But the other way around, what's that then? So if I put 1 in the first bracket and then 2 in the second bracket, then I'm going to have 3x times 2, that's 6x, and 5x. So if I make that one positive, to make that give me positive 6x, and make that one negative to give me minus 5x, then 6x minus 5x is the 1x I'm looking for then, isn't it? So then this then factorizes into 2 lots of 3x minus 1, 5x plus 2 then altogether, and that's my final answer. 2 lots of 3x minus 1, 5x plus 2. Question 12, the graph shows the speed of a car during the first 40 seconds of a journey. It's a speed time graph, speed on the y-axis and time on the x-axis. Write down the acceleration of the car between 10 seconds and 25 seconds. Okay, well, acceleration is the gradient of a speed time graph, isn't it? And between 10 seconds and 25 seconds, not a lot happening here. Line is flat. So the gradient is 0, which means there is no acceleration between 10 seconds and 25 seconds, so it's 0. B says, work out the average speed of the car in meters per second during the 40 seconds you must show you're working. Alright, so the average speed of the car in meters per second during the 40 seconds. So to work out the average speed, we're going to use a DST triangle, distance, speed, time. Now what do we know and what don't we know? Okay, well obviously we're looking for the speed. That's the thing it wants us to find in the question. So that's the one we don't know. Right, do we know the distance? Well, if you think about it, distance is the area under the speed time graph, isn't it? So if I want to know what the distance is, I need to know what this area of my graph is. That's the first thing I need to work out. Now this shape is a trapezium, and then the formula then for the area of a trapezium is half a plus b times h, isn't it? Okay, so what is half a plus b times h here? Half a plus b h. Well, half is half. What's a and b? A and b are two parallel sides. So a then is going to be that that line at the top there, the line going from 10 to 25. So that has a length of 15. B is the other parallel side there. That's going from 0 to 40. So that has a distance of 40. Okay, and then the h is the distance between them, which is that distance there, isn't it? Now, just reading off on the scale, the top of this trapezium is at a height of, what's that, 10 units between 15 and 20. Each one is, all right, two of them is 1 unit then, so that's 16, 17, 18 units high. So that's going to be a height of 18. So then the area of the triangle is half times 15 plus 40 times 18. Well, 50 plus 40 is 55. Half of 18 is 9. So it's going to be 55 times 9. That comes out to be 495. So that's an area of 495. So we know the distance now. It's 495. Speed is what we're trying to find. Time, well, the length of the whole journey was 40 seconds. So now we're in a position that we can work out the average speed. Cover up the thing I want to find. I want to find speed. That tells me what to do with the other two. Speed is equal to distance traveled divided by time taken. So in this case, it was 495 divided by 40. What's that then? 495 divided by 40. That's 12.375. 12.375. What are the units? I guess that's in meters per second, isn't it? 12.375 meters per second. Question 13a. Here's a function. We've got input. It's multiplied by t, and then 2 is subtracted, and we get the output. When the input is 6, the output is 18. Find the value of t. Okay. Well, if I feed 6 into this function machine, the first thing that's going to happen is it gets multiplied by t. That's going to give me 6t. And then when I subtract 2, that's going to give me 6t minus 2. Okay? And we're told, though, that that output is equal to 18. So comparing or just equating these things, I know that 6t minus 2 must be equal to 18. So I've got a linear equation in t that I can go on to solve. Adding 2 to both sides, just to get rid of that 2. That's going to give me 6t is equal to 20, and then dividing both sides by 6. And that's going to give me t is equal to 20 over 6, which is, what's that, 10 over 3. I'm just going to leave it as a fraction, 10 over 3, because I can't bother to write down a recurring decimal or round it off. So 10 over 3 is accurate. I'm going to leave it as 10 over 3. Part B says here is another function. When the input is x and the output is y, write an algebraic expression for x in terms of y. Now, things that are put in bold for a reason, and the reason is students usually overlook it. So x in terms of y. So we're actually working backwards in this case. We want x in terms of y. So we want x equals and not y equals. So I'm going to go through this function machine backwards. So if I had y, if I had to add something, 3 to something to get y, then going back the other way, I must have added y minus 3 here. I must have had y minus 3 here, because when I added 3 to it, I get y. And then if I had, my outcome was y minus 3 after dividing it by 4, I must have had 4 lots of it to start with. So I must have had 4 lots of y minus 3 here, so that when I divide it by 4, I ended up with just y minus 3. So then these two things must be equal to each other. So x is equal to 4 lots of y minus 3 in this case. Okay. My 3 is not looking very convincingly free-like. 3, that's more free-ish. Okay. So x equals 4 lots of y minus 3. Brackets are important, have to put the brackets in. Question 14a. The time taken to paint a wall is inversely proportional to the number of people painting it. It takes 40 minutes for 3 people to paint a wall if nobody stops painting. Layla, Mia and Nina, that's a bit of a tongue twister that, Layla, Mia and Nina start painting the wall. After 10 minutes, Layla stops painting, naughty Layla. She leaves Mia and Nina to finish painting the wall. Assume that Layla, Mia and Nina paint at the same rate, work out the total time taken to paint the wall. Okay, so if it takes 40 minutes for 3 people to paint the wall, I think the easiest way, rather than set this out as an inverse proportion and working out the equation, etc., probably is just to work out the number of work units. So the number of work units here, if you think about it, I kind of think of work units, how much would it take one person to do something. So if you've got 40 minutes, 3 people, then they're each contributing 40 minutes. That means that there are 40 times 3, there's 120 units of work that need to be done. Okay, so if it takes 3 people 40 minutes, it's going to take one person 120 minutes. So overall, there's 120 minutes worth of work. Now, if Layla did 10 minutes of that time and then stopped, so 3 workers then work for 10 minutes, that's 30 minutes worth of work then, isn't it? So the 3 of them are working for 10 minutes, isn't it? Layla, Mia and Nina are all on the case for 10 minutes, and so together they complete 30 minutes worth of work. So the remaining work units is going to be 120 minus the 30. It's going to be 90 work units left then, isn't it? Okay, so then 2 workers, time for 2 workers is going to be that 90 minutes remaining divided by the 2 people working. So that the 2 girls are going to work on for another 45 minutes. So then the total amount of time is going to be the 10 minutes that all 3 of them worked plus the 45 minutes that 2 of them worked, giving a total of 55 minutes. Okay, that's the way I would have worked it out. Okay, other methods are available, but yeah, 55 minutes is the answer. Okay, part B says y is inversely proportional to x cubed. Y is 16 when x is 2. Find the value of y when x is 8. This is more kind of classic proportionality problem. Y is inversely proportional to x cubed. I would say y is inversely proportional to 1 over x cubed then. Okay, so that little fishy symbol is a symbol of proportionality. Next step is to replace it though. Replace the little fishy symbol with equals k. So y equals k over x cubed. And then the idea now is to work out what k is. Now generally they'll give you a pair of values that go together like they do here in order for you to work out what k is. Okay, so when y is 16, x is 2, so that means we can sub those 2 values into the equation, and then the only thing we won't know then is k. So 16 is equal to k over 2 cubed. 2 cubed is 8, so cross multiplying that then k then is going to be 16 times 8. What's 16 times 8? 16 times 8, apparently that's 128. So k is 128. So therefore, the equation linking y and x is going to be y is equal to 128 over x cubed. Okay? Right, so now we've got the equation, we can go on and find out the value of y when x is equal to 8. So when x equals 8, then y is going to be 128 divided by 8 cubed. What is 8 cubed? 8 to the power of 3, that's 512. So then y is going to be 128 over 512. 128 divided by 512. What fraction is that? That's a quarter. So then y is going to be equal to a quarter. Okay, that's my answer. Y is 1 over 4. Question 15. The region R is shown on this grid. A is the point 0,3 and B is the point 3, 4.5. Show that the equation of the straight line through A and B is 2y is equal to x plus 6. Okay, so we're told that A is the value, is the point 0,3. I'm just going to draw that on the diagram. So that's 0, 3, and B is 3, 4.5. Okay, so if we wanted to work out the gradient of this line, what we'd need to do is work out what change in y is divided by change in x. Okay, now I can see from the diagram that the change in y is going to be 1.5. Okay, it's 1.5 squares, and the change in x is 3. So then the gradient is going to be the change in y over the change in x, which is 1.5 divided by 3, which I believe is a half. Okay, so we've got a gradient of a half. So equation is going to be of the form y is equal to a half x plus c. But we know the y-intercept as well. Look, the c value is here. So c equals 3 because the line passes through the y-axis at 3. So it's not half x plus c. It's going to be a half x plus 3 then, isn't it? Okay, because we know that c is equal to 3 from the diagram. So I've got y equals a half x plus c. It doesn't quite look like the form we've got here. But if I just multiply both sides through by 2, that means I'm going to get 2y is equal to x plus 6 as desired. Okay, so we've done that first part. Write down the 3 inequalities that define the region R. So we've got one of the equations, 2y equals x plus 6. We need to work out which way the sign goes in. The other two lines, I've got a vertical line which passes through 3. So that equation is the form x equals 3, and I've got a diagonal line with a gradient of, well, it's going down 1 for every one it goes across. It has a gradient of -1 and a y-intercept of 3. So I've got 2y equals x plus 6. I've got x equals 3, and the other one is a line sloping down 1 unit down for every unit across. It's going to have a gradient of -x, and it passes through the y-axis at 3, so it's going to be y equals -x plus 3. So they're the equations of each of the line, but we need to work out the inequalities that go with them. Now what I tend to do is just kind of guess them and then pick a point that I can test them on. So I'm going to pick a point within the range I want, which is the point 2, 2. And as I go through and write the inequality symbols in, I'm going to see if I can work out which way around they go from that. Alright, so for the first one, the line we worked out first, we had 2y and x plus 6. Now, is it less than or equal to, greater than or equal to? Okay, now my feeling is that the x values are going to be bigger than the y values. So I think it's going to be this way around, but I can just test that by picking a point that lies in the range. So let's say, well, we pick 2, 2. So if x is 2, then 2 plus 6 is 8, and 2 times 2 is 4. So yeah, it does go that way around. Okay, so that seems to work. Now it's greater than or equal to because the line is solid and not dashed. Okay, then x equals 3 is my vertical lines. I want the points to the left of them, which means it looks like the x values are going to be less than 3 then, isn't it? So x is less than 3. Now again, because it's a solid line, we're going to make it less than or equal to 3. And then finally, I've got this line, y equals -x plus 3. Now here it looks like the y value is going to end up being bigger than the x values. So I think it's going to be y is greater than -x plus 3. So using my reference point 2, 2, if y is 2 and x is 2, then I'd get 2 is greater than -2 plus 1. 2 is greater than 1, which is true. Okay, so I do think it goes that way around. And there's just a single greater than. It's not greater than or equal to, because on the diagram I've got a dashed line, which means the line itself is not part of the range. Okay, so they're my 3 inequalities that define the region R. Question 16. A plane flies from London to Tokyo. The distance is 9,600 kilometers, correct to the nearest 100 kilometers. The plane travels at an average speed of 820 kilometers per hour, correct to the nearest 10 kilometers per hour. Calculate the shortest possible flight time of the plane. Give your answer in hours and minutes, correct to the nearest minute. You must show you're working. Okay. So first things first, we need to consider the limits of accuracy for our two values that we are using in this calculation. So we got distance, and we know that distance is 9,600 to the nearest 100. Now if you imagine the scale that was going up in hundreds and you had 9,600 on it, then the next number up on that scale would be 9,700, and the one before it would be 9,500. And so the ones that round to 9,600 are the ones that are going to be halfway between or closer then, aren't they? That range of numbers is going to round to 9,600. So where does it change from rounding up to rounding down? Well, halfway between 9,500 and 9,600 is 9,550. So bigger than that's going to round up, smaller than that's going to be round down. And at the other end, you've got 9,650. So bigger than that, you're going to round up, smaller than that, you're going to round down. Okay, so they're my two limits for the distance. Now, the speed, that is 820 to the nearest 10 kilometers per hour. So again, if I imagine a scale, the next digit up on that scale, if I was going up in tens, would be 830, and the one previously would be 810. And so the numbers that rounded to 820 are going to be 815 and 825. They're my two limits for the speed. Okay, right, so calculate the shortest possible flight time. So this is a distance, speed, time problem, isn't it? So I'm going to draw my distance, speed, time triangle. So what is the distance, what is the speed, what is the time? Okay, now I want to know the time, don't I? So my calculation is for time, and time is equal to distance divided by speed. Now I want the shortest possible flight time. So which values are going to give me the smallest value of time? Well, if I want the smallest value of time, I'm going to need the smallest distance that we travel. It's going to be that one there, isn't it? The 9550. Because if I pick a bigger number, I'm going to end up with a bigger time. So the distance I'm going to use is the lower bound of my numbers there. It's going to be 9550 kilometers. And my speed, which speed am I going to pick? Well, if I want to get the smallest possible time, I want to be traveling at the fastest possible speed, don't I? Because the number you divide through by, the bigger the number you divide through by, the smaller your outcome is going to be. So I'm going to be using the upper bound of the speed, which is 825 kilometers per hour. And don't worry that 825 technically rounds up to 830, but 824.9999999 rounds down, and that's pretty much the same value. Okay, so then I want to work out what my time is from those two values. So subbing in those limits into the calculation. So 9550 divided by 825, what's that then? That's going to be 9550 divided by 825. That comes out to be 11.575. I'm going to round it off to 11.6. No, I'm not, because I need to put it in minutes and seconds first. So I've got that display on my calculator, 11.5757. If I press the time key, it should rewrite it in hours and minutes and seconds. Now I make that, let's just write it down as a decimal first. That's roughly 11.58, which in hours, minutes and seconds, pressing the timey-wimey key, is coming out to be 11 hours, 34 minutes, and 32 seconds. So am I going to round that up or down then? So 32 seconds is more than half a minute, so I feel like I should round that up. So to the nearest minute, it's going to be 11 hours and 35 minutes. I'm going to round up. Okay, because 32 is beyond halfway from 1 to 60, isn't it? Okay, 11 hours 35. Question 17. Charlie weighs many apples. The weight of the apples are summarized below. The heaviest apple was 75 grams, the range was 50 grams, the median was 60 grams, the lower quartile was 45 grams. 50 grams of the apples weigh between 45 and 65, the mean was 63 grams. Write down the interquartile range for the weights of the apple. Right, so the interquartile range is the difference between the lower quartile and the upper quartile, and it represents the middle half of the data. Now you can see that the lower quartile is given as 45. It doesn't specifically tell you the upper quartile, but it does say that 50% of the apples weigh between 45 and 65. So this 65 here must be the upper quartile. Q3, and that's Q1, isn't it, the lower quartile? Okay, so then what is the interquartile range? So the interquartile range is going to be Q3 minus Q1, which is 65 minus 45, which is 20. Write down the percentage of apples that weigh between 45 grams and 60 grams. Well, we know that 45 grams is Q1 because we just worked it out a minute ago. 45 is Q1. Okay. What's 60 grams? 60 grams, that's the median, isn't it? So that's Q2. Now, Q1 lies 25% of the way through your data, and Q2 lies 50% through your data. So what is the percentage of apples that weigh between 45 and 60? It's going to be the difference between 50 and 25. It's going to be 25%, isn't it? Okay, so 25% of the apples weigh between the lower quartile and the median. It just happens to be how it works. Right, finally, draw a box plot to show the distribution of weights of the apples. Okay, so box plots, important values for box plots. You need the the highest value and the lowest value. So you've got the highest value here. That's the highest. Have we got the lowest? No, we don't have the lowest, but we've been told the range. So if I subtract the range from the heaviest apple, I'll get the lightest apple then, won't I? So then the lowest is going to be equal to the highest, 75 minus the range, which is going to be 25. Okay, so the highest apple is 35, the lowest apple is 25, the median is 60, the lower quarter is 45, the upper quarter is 63. You've got all the values we need then, isn't it? I'm going to mark each of those values first on the scale. So the lightest apple was 25, so I'm just going to draw a line at each of these first. So lightest apple at 25, lower quartile was at 45, median was at 60, upper quartile was at 65, and then heaviest apple was at 75. Okay, when I've got all my lines on and I can just finish it off, I'm going to make this bit in the middle into a box because it's a box plot, so it should be a box in the middle. Box, box. Now, box plot is the boring name for these. They used to be called consistently box and whisker diagrams, which is a little bit more descriptive because once you've got your box, then you've got whiskers reaching it out to the highest and lowest value. So I prefer the name box and whisker diagram because it's a bit more descriptive. So you have your box in the middle and then you have your whiskers reaching out to your highest and lowest value like that. Okay, that looks good. Part C says Charlie eats 2 of the apples. The apples they eat weigh 58 grams and 66 grams. Charlie says the mean weight of all the apples was 63 grams. I ate one apple that weighed less than the mean and another apple that weighed more than the mean. Therefore, the mean of the remaining apples will still be 63 grams. Is Charlie correct? Well, if you think about it, the difference between 63 and 58, these have a difference of what? That's minus 5. So the 58 gram apple was 5 grams below the mean. Whereas the 66 apple, that's 3 grams above the mean. Now, if the one he ate was 58 and the one he ate was 68, so the difference between them was -5 and +5, then yes, they would kind of cancel each other out and the remaining apples would be unchanged. Okay, but here, because the lighter apple was significantly further away from the mean value than the heavier apple, then actually this is going to move the mean. Okay, so I'm going to have to write that in words somehow. I'm going to say the difference between the mean and the 2 eaten apples is -5 and 3, because these do not sum to 0, the mean value will be affected and will become slightly higher. Question 18. The circle's equation x squared plus y squared equals 100. The sketch shows a circle and 2 points A and B which lie on the circumference of a circle. Write down the coordinates of the point A. Okay. Well, we've been given the equation of the circle as x squared plus y squared equals 100. Now, generally, the equation of circles is x squared plus y squared is equal to r squared. So in other words, the 100 there is matching with the r squared here. So if r squared is 100, then r is going to be the root of 100. It's going to be 10, isn't it? Okay. So that means this is 10 units to the right of the origin. So its coordinates are going to be 10, 0. Okay. Point B is x coordinate 3. Find the exact value of the y coordinate of the point B. Okay. Well, if we want to know the y coordinate given the x coordinate, all we've got to do is sub it into the equation and find it out, don't we? So I know if x is 3, then x squared plus y squared equals 100 is going to be at x equals 3. I'm going to get 3 squared plus y squared equals 100. In other words, y squared is going to be 100 minus 3 squared, which is 9. So y is going to be the root of 91. Okay? Now, find the exact value. I'm just going to write down root 91 then. Does that simplify down? I'm going to check on my calculator. Root 91. No, it doesn't. So I'm just going to leave it as root 91. Another point C lies on the circle and has a y coordinate that is 7 times its x coordinate. Find the 2 possible pairs of coordinates for point C. Give your answer in exact form. Well, if the y coordinate is 7 times its x coordinate, then y is equal to 7x. And so the coordinate would be x 7x then, wouldn't it, like that? So subbing in x and 7x for x and y, I'm going to get x squared plus 7x all squared is equal to 100. In other words, x squared plus 49x squared is equal to 100. In other words, 50x squared is equal to 100. In other words, x squared is equal to 2. In other words, x is equal to root 2. Okay, so well, it's plus or minus root 2, I guess, and that's where the 2 solutions come from. So either I'm going to get x is root 2 and minus root 2, and remember y is 7 lots of x, so then y is going to either be 7 root 2 or minus 7 root 2, then like that. Okay. Question 19. PQS and QRS are triangles. PQ is 9, QR is 8, RS is 13, angle QPS is 30, and angle PSQ is 15. Now it's worth just checking through each of those actually on the diagram. They all are already, but you know, if they didn't put it on and you'd missed it, you're going to struggle to answer the question. Calculate the angle QSR. Where's QSR? QSR, it's down here. It's this one. This is the one we need to find. Okay. Correct to one decimal place, you must show your working. So we've got two non-right angled triangles pushed up against each other. We know two things in the top one and we know three things in the bottom one. So I'm guessing we're going to have to start in the bottom one, find something that they have in common, and then move on to the second triangle. Okay. Now the thing that these two triangles have in common is this line that runs down the middle of them. Okay. QS. So the first thing I'm going to have to do is use bottom triangle to find QS. Once I know QS, I've got three things in the other triangle that I can go on and find the fourth thing. All right. Plan of action is now settled. Right. So let's start in triangle PQS. Okay. So in triangle PQS, what have we got? So we've got two angles, a side, and we want another side. Can we use the sine rule? I think we can. Straightforward use of the sine rule here. So I've got 9, which is opposite angle 15, and I've got 30, which is opposite the side I want to find, okay? Which I'm going to call X, because I lack imagination. Okay, so I know that I'm going to call that one X, going to find it using the sine rule. I know it's the sine rule because sine rule is about opposite pairs, so I'm looking for two pairs of sides and angles that go together, which I've got here. Now I want to find the side, so I'm going to write the sine rule down with the thing I want to find on the top, which is the side. So I want P over sine P is equal to S over sine S. Okay, so P is the side opposite angle P, which we know is X. Sine P is sine 30. And that's equal to S, which I know is 9, divided by sine S, which is sine 15. Okay? So rearranging then for X, X is equal to 9 sine 30 over sine 15. Okay? So just tapping that into the old calculator. So 9 sine 30 divided by sine 15, I make that 17.4. So X is 17.4. There's a little bit more than 17.4. I'm going to write 17.4 down, but I'm going to keep that full display in my calculator for in a minute. Right, so now I've found that communal side between the two triangles. I'm going to switch over to the other triangle now. I'm going to go to triangle QRS. Okay. So in triangle QRS, so now I know three sides and I want an angle. So if I know three sides on an angle, that is the cosine rule, isn't it? Okay, so writing down the cosine rule for angle S, I'm going to get S squared equals Q squared plus R squared minus 2QR cos S. Remember, it's the S I want to find. Okay, so I need to rearrange and make S the subject of this. Okay, so rearranging, I'm going to get 2QR cos S equals Q squared plus R squared minus S squared. Dividing through by 2QR, I'm going to get cos S equals Q squared plus R squared minus S squared over 2QR. Now you could just remember that rearrangement straight off, but I haven't got the headspace to remember that. I just remember the main one and I know how to convert it into the other one. Okay, so now I've got it in the form I want it to be in. Matter of just subbing everything in. So side Q is the one opposite Q, which is 13, so 13 squared, plus R is the side opposite angle R. That's our X value. That's our 17.4. Okay, or thereabouts, squared, minus S squared. S is the side opposite S, which is 8 squared. And that's over 2 times 13 times 17.4 again. Okay, so it's going to be a big thing to type into the calculator. So what we want, I'm going to use the fraction key, I think, just to make it a little bit easier. So on the top of the fraction, I'm going to use 13 squared, plus answer squared minus 8 squared, and on the bottom I've got 2 times 13 times answer. Okay, now that's going to give me a decimal, 0.9, and then what I want to do is then find the inverse cosine of that. So S is going to be inverse cosine of that answer. So shift cos answer, and that's going to give me 25.7. So that's my final answer, 25.7. Question 20, write as a single fraction in its simplest form 10 minus 6x plus 45 over 3x plus 5. Okay, so when you're adding and subtracting fractions, you need to have the same denominator, don't you? Okay, so how can I turn 10 as into a fraction over 3x plus 5? Well, I can just write 10 lots of 3x plus 5 over 3x plus 5, can't I? Okay, so now I've got, now obviously those two things would cancel leaving you 10, but I don't want to cancel it because I want to combine it with this other thing that's next to it. Okay, so writing down that thing. So you can see now I've got two fractions with the same denominator, here and here. So I can rewrite that as a single fraction over one denominator of 3x plus 5. Okay, so what have I got? I've got this thing on the top here, 10 lots of x, 3x plus 5. I'm just going to multiply that out while I go, while I'm at it. So 10 lots of 3x is 30x, and 10 lots of 5 is 50. So that's going to become 30x plus 50. And I'm going to be minusing 6x plus 45. Now when I subtract 6x plus 45, it's going to become 6x minus 45, isn't it? Because I'm subtracting 45 as well as 6x. Okay, so I'm just going to flip the sign of that one, just make it a bit easier. And then I'm going to collect like terms. Oh, just noticed I've missed that O off there of the 50 when I wrote it down. Let's just add that in first. That would have been a bad mistake, wouldn't it? So let's go ahead now and collect like terms. So terms in x, I have 2. I've got a 30x and a minus 6x. That's going to give me 24x. And constants, I've got a plus 50 and a minus 45, which gives me plus 5. And that's all over 3x plus 5. Okay? Right, I'm not going to be able to factorize or simplify anything there, have I? There's no common factor for 24 of x and 5, which is going to cancel with what's below. So that's as far as I'm going to get. So that's my final answer. 24x plus 5 over 3x plus 5.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.